Welcome to my channel. In this lesson, we're going to be focusing on how to find the vertical asymptotes, horizontal asymptotes, and slant or oblique asymptotes of functions. We're going to graph the functions and find the domain and range of each of the functions we're going to be solving. And let's start with this question. Y is equals to 1 divided by x minus 2. We're going to be finding the vertical asymptote, the horizontal asymptote, and then graph this function to find the domain and the range. So let's start with the vertical asymptote. To find the vertical asymptote, we set the denominator to 0. So if you set the denominator to 0 and add 2 to both sides, you have that x is going to be equals to 2. Now the vertical asymptote is the point where x is equals to 2. Then let's find the horizontal asymptote. To find the horizontal asymptote, if you look at this question, you see that this function is bottom heavy. Alright, so it means that any value you plug in for this x, the denominator will always be greater or higher than the numerator. So in that case, the horizontal asymptote is going to be equals to 0. Anytime a function is bottom heavy, a rational function, then the horizontal asymptote is 0. So having gotten the vertical and horizontal asymptotes, let's go ahead and graph the function. So this is just a sketch. Now the vertical asymptote is at the point where x is equal to 2. So here is the vertical asymptote. Alright, and then horizontal asymptote is at the point where y is equals to 0. That's at this line. And the graph may be here or here. So let's find out where it will be actually. So let's plug in a value that is at the right of the vertical asymptote to this function and then find the value of y there. So let's pick x to be 3. So I have y is equals to 1 divided by 3 minus 2, which is equals to 1 over 1, which is equals to 1. So when x is equals to 3, y is equals to 1. So let's plot this. So this is 3, and then this is when y is equals to 1. Okay, so this is how this graph is going to be. It's not going to be below the x-axis. So let's check for this side. It can either be like this or like this. So let's pick a number that's at the left of the vertical asymptote. Let's pick 1. So when x is equals to 1, then y is going to be 1 divided by 1 minus 2, which is equals to minus 1. So when x is 1, y is minus 1. Okay, so let's plot it. We have x here to be 1 here, which is here, and then y to be negative 1, which is, let me say, at this point. So this is how this graph is going to be. So what is the domain and range of this function? So here the domain is going to be, so you have negative infinity to positive infinity, and then here we have negative infinity to positive infinity. So the domain are possible x values that can make this function defined. And then to write the domain, we are going to remove only the vertical asymptotes. Alright, so here is going to be from negative infinity, comma, then we are going to remove 2, then union 2, comma, positive infinity. So this is the domain of this function. Now what about the range? To find the range, we remove the horizontal asymptotes. So it's going to be from negative infinity to 0. Then we're going to remove that 0, union 0 to positive infinity. And then this is the range of this function. Now let's look at this function. Y is equals to 1 divided by x plus 4 plus 5. Let's find the vertical asymptotes, the horizontal asymptotes, and then the domain and range of this function. So to start with vertical asymptotes, we set the denominator to 0. If you set it to 0 and solve for x, you'll find that x is equals to -4. So this is the vertical asymptote. Now the horizontal asymptote. Now if you look at this part of this function, you see that it's bottom heavy. So that part of the function is going to be 0, right? Then plus 5, which is equals to 5. So the horizontal asymptote of this function is going to be equals to 5. Then y is equals to 5. So let's graph this function and find the domain and range. So you have negative infinity, you have infinity here, you have negative infinity, and then infinity here. So let's indicate the vertical and horizontal asymptotes first. So the vertical asymptote is at the point where x is equals to -4. So here is our vertical asymptote, and then the horizontal asymptotes move to a point 5 to the up of the graph. So we have 1, 2, 3, 4, then 5. Here is the horizontal asymptote. So let's graph this function now. Let's pick an x value that is at the right of the vertical asymptote. In this case, let's just pick -3. Alright, so this is -4. So let's just pick -3. Have that y is equals to 1 divided by -3 plus 4, then plus 5. So you have that y is equals to 1 over -1, or rather this is plus 1. 4 minus 3 is 1, then plus 5. So 1 over 1 is 1. 1 plus 5 is equals to 6. So when x is equals to -3, then y is equals to 6. Now let's plot this on the graph. So when x is equals to -3, which is here, then y is equals to 6. Here 1, 2, 3, 4, 5, 6, maybe okay at this point. Alright, so it means that this is how the graph is going to be, the curve. So now for the one that will be at the left hand side of this vertical asymptote, it can be like this or like this. But let's find out. Let's pick a number that is at the left of this vertical asymptote. Let's pick -5. If you plug in -5 here, we're going to have y is equals to 1 divided by -5 plus 4 plus 5. So -5 plus 4 is -1. Then -1 plus 5 is equals to 4. -5, 4. So let's plot it. So we have -5 as our x value, which is at this point, and then we have 4. So as our y value, here is 1, 2, 3, 4. So which is this point. So this is how this graph is going to look like. Now let's find the domain and range of this function. So remember, domain, we are going to remove the vertical asymptotes, and then range, we will remove the horizontal asymptotes. So the domain of this function is -infinity, the vertical asymptote is -4. So we're going to remove it, then union -4 to infinity. And then for range, you remove the horizontal asymptote. It's going to be -infinity, 5, then union 5, infinity. So this is the domain and range of this function. Now we have y is equals to 6x minus 3 divided by 2x plus 4. Let's find the vertical asymptotes, the horizontal asymptotes, the domain and the range of this function. The vertical asymptotes is simply to set the denominator to 0. You have 2x plus 4 is equals to 0. If you subtract 4 from both sides, you have 2x, this will cancel. You will left to 0 minus 4 is -4. And if you divide both sides by 2, you have x is equals to 4 divided by 2 is 2, so -2. Then the vertical asymptote of this function is at the point where x is equals to 2. Now let's find the horizontal asymptotes. If you look at this function, you see that the degree of the numerator and the denominator are the same. So if they are the same, you just focus on the coefficients. So in this case, the coefficient is 6/2. So the horizontal asymptote is going to be equals to 6 divided by 2, which is equals to 3. Alright, so we now see that 3 is the horizontal asymptote. So let's graph the function. Now all of these are just rough sketches. Now the vertical asymptote is at the point where x is equals to -2, so which is this, and then the horizontal asymptote is at the point where y is equals to 3. Then here is it. Now we don't know if the curve is going to be here or here or here or here, but then we are going to find out very soon. So let's focus on the right hand side of this vertical asymptotes. Let's pick -1, which is this point, and put it into this function. So have y is equals to 6 multiplied by -1 minus 3 divided by 2 multiplied by -1 plus 4. So 6 times -1 is -6, -6 minus 3 is going to be equals to -9 divided by 2 times -1 is -2, -2 plus 4 is equals to 2. So -9 divided by 2 is equals to -4.5. So have the coordinates to be x is -1 and then y is -4.5. Now if you graph this, you're going to see that here we have -1 for x, and then y is -4.5, which is at this point 1, 2, 3, 4, then 5 at this point. So it's going to be, the graph is going to be like this. So then to the left hand side of this vertical asymptote, here is -2, so let's pick -3. So if you plug in -3 here, you're going to get y is equals to 6 multiplied by -3, then minus 3 divided by 2 multiplied by -3 plus 4. Then y is going to be equals to 6 times -3 is -18. -18 minus 3 is -21 divided by 2 times -3 is -6. -6 plus 4 is -2. And then this and this will cancel. 21 divided by 2 is going to be equals to 10.5. Now the coordinates are going to be -3, 10.5. So here x is equals to -3 at this point, and then y is 10.5, which is way above the horizontal asymptotes. So here, this is where the graph is going to appear. Alright, so having graphed it, let's find the domain and range of the function. So remember, domain are the possible x values that will satisfy this function and make it to be defined. And then in writing domain, you remove the vertical asymptotes. So here we have -infinity, and then we have +infinity. The domain is going to be -infinity, comma, the vertical asymptote is -2, then -2, comma, infinity. Alright, now the range is going to be -infinity, comma, then you remove the horizontal asymptote, which is 3, union 3, comma, infinity. So this is the domain and range of this function. Y is equals to s squared plus x minus 6 divided by s squared plus 7x plus 12. The first thing we need to do here is to factor out the numerator and the denominator. So let's focus on the numerator. we have x squared plus x minus 6. So two numbers that will multiply to get -6 but add to get 1. Then that two numbers are 3 and -2. 3 times -2 is -6. 3 minus 2 is 1. So we're going to replace x with 3x and -2x. So this is 3x minus 2x minus 6. So you can write it in any order. Any of these two can come first. So let's factor out. X squared divided by x is x. 3x divided by x is plus 3. Now what is common between 2x and 6? What is common there is 2. Minus 2x divided by minus 2 is going to be x. And then minus 6 divided by minus 2 is going to be 3. Once this and this are the same, then you're on the right track. So let's factor out this again. So here and here, what is common is x plus 3. If you factor out x plus 3, we are going to be left with x here and then minus 2 here. And so we are done factoring the numerator. Then let's replace it with what we have, x plus 3 and then x minus 2. So let's focus on the denominator. We have x squared plus 7x plus 12. Well, this is 12 actually. So two numbers that will multiply to get 12 but add to get 7. They are 3 and 4, right? 3 and 4. 3 times 4 is 12. 3 plus 4 is 7. Let's replace 7x with 3x and 4x. Both are positive. We have 4x plus 3x, then plus 12. And then let's factor out by grouping. Now x is common between x squared and 4x. Let's factor it out. X squared divided by x, we have x. 4x divided by x, we have 4. Then plus, between 3x and 12, 3 is common. So 3x divided by 3 is x, plus 12 divided by 3 is 4. So let's factor out again. So x plus 4 is common. Then we'll be left with x here and then plus 3. So we have that the denominator is equals to x plus 3, x plus 4. So this and this will cancel. Now this term that cancelled constitutes the whole in the graph. So we have x plus 3. If you set it to 0 and solve for x, you get x to be -3. Now the whole appears at the point where x is equals to -3. So whole is at where x equals to -3. Now let's use the surviving part of this function and find the horizontal and vertical asymptotes. So if you set the denominator to 0, you get your vertical asymptotes to be x is equals to -4. And then seeing that the degree of the numerator and the denominator are the same, and then the coefficient of this x is here are 1, then the horizontal asymptote is going to be 1/1, which is equals to 1. Now let's plot the graph of this function. The vertical asymptote is at the point where x is equals to -4. So here is it. Then the horizontal asymptote is at the point where y is equals to 1. So here is it here. And then the whole, we're going to find the y coordinates of this whole. So if you plug in -3 into the surviving part of this function, which is y is equals to -3 minus 2 divided by -3 plus 4, which is going to be equals to -3 minus 2 is equals to -5, -3 plus 4 is equals to 1. So y is equals to -5. So the coordinates are -3 and -5. Now let's locate it on the graph. So -3 is, we have 1, 2, 3. So here is -3. And then -5 is down here. I have 1, 2, 3, 4, 5. So here is -5. Now here is the whole. So this is the whole. Actually, this is how this graph is going to look, since the whole is at the bottom right hand side of the vertical asymptotes. But then let's just confirm. So let's pick a number that is at the right of this vertical asymptote. Let's pick 0. So I have y is equals to 0 minus 2 divided by 0 plus 4, which is equals to -2 divided by 4 is -0.5. So the coordinates are 0 and -0.5. So which is just here. Now is at this point, which means that this graph will still appear at this region. So let's focus on the left hand side of this vertical asymptote. Let's pick a number -5. So if you plug in -5 here, we're going to have with that y is equals to -5 minus 2 divided by -5 plus 4. So equals to -5 minus 2 is -7 divided by -5 plus 4 is -1. So have that y is equals to 7. And the coordinates are -5, 7. So if you plot this, you have -5 here, and then 7 should be way up here. So this is how this graph will look. Then the domain, we have negative infinity to infinity. Now we have negative infinity here to infinity. Now to write the domain in this case, we remove the vertical asymptotes and the x coordinates of the whole. So first we're going to remove the vertical asymptote, which is -4. So I have minus infinity, 4, then union 4, now we now remove the x coordinate of the whole, which is -3, then union -3, infinity. Now this is the domain of this function. And now for the range, we remove the y coordinates of the whole and then the horizontal asymptotes. So we're going to write range as -infinity, the y coordinates of the whole is -5, then union -5, we remove the horizontal asymptotes, which is 1, then union 1, infinity. So this is the range of this function, and then this is the domain of the function. Let's solve one more question. We have y is equals to 3x squared minus x plus 1 divided by x minus 3. First thing we do is to find the vertical asymptotes. Just like we have been doing before, you set the denominator to 0. If you solve it, you see that x is equals to 3. Now, if you look at this function, you see that the degree of the numerator is higher than that of the denominator, so it is top wavy. In this case, there is no horizontal asymptotes. What we have here is slant or oblique asymptotes. Now, to find the equation for the slant asymptotes, let's perform this division. We have x minus 3. Let's use x minus 3 and divide the numerator, which is 3x squared minus x plus 1. Now 3x squared divided by x, we get 3x. Then let's multiply 3x times 3x is 3x squared. 3x times -3 is -9x. Now let's subtract 3x squared minus 3x squared. This one is 0. Minus times minus is plus. Now minus x plus 9x is equals to 8x. Now let's break down this one here. We have plus 1. So 8x divided by x is going to be equals to 8. let's perform multiplication. 8 times x is equals to 8x. Then 8 times negative 3 is equals to negative 24. Then let's subtract once again. 8x minus 8x is 0. Minus times minus is plus. 24 plus 1 is equals to 25. Now, since this has a remainder, it means that this denominator of x minus 3 is not a factor to this numerator. So it means that this x minus 3 can divide numerator without remainder. So there's no need of us trying to factorize the numerator to know if anything can cancel out, because if it cancels out, it means that we have a whole. But since there's a remainder here, then this x minus 3 is not a factor. So we don't have to know if the numerator is factorizable or not. So this expression here is the equation for the slant asymptote. So y is equals to 3x plus 8 is going to be the equation for the slant asymptote. So let's graph the function. From the equation of a straight line, we have that y is equals to mx plus c. So this c here represents the y-intercept of the graph. And so let me just represent this as we have 1, 2, 3, 4, 5, 6, 7, 8. I have 1, 2, 3, 4, 5, 6, and so on. So here's the intercept on this graph. And then remember, this is 3 over 1. So it means rise over run. So 1 to the right, 3 up. So 1 to the right, we have 1, 2, 3 up. Or we have 1 to the left, 1, 2, 3 down. 1 to the left, 1, 2, 3 down. 1 to the left, 1, 2, 3 down. Now the vertical asymptote is at x is equals to 3. So at this point is our vertical asymptote. Remember this graph, then this is the vertical asymptote. Then here we have 4. So let's pick a number that is at the right of this vertical asymptote. In this case, it's going to be equals to 4. So I have y is equals to, let's plug in 4 into this equation. So y is equals to 3 multiplied by 4 square minus 4 plus 1 divided by 4 minus 3. Alright, so we have that y is equals to 4 times 4 is 16. 16 times 3 is equals to 48. Then minus 4 plus 1 is equals to minus 3. And then 48 minus 3 is equals to 45. Then this will be divided by 1. So y is equals to 45. Now the coordinates are 4 and 45. So we have that x is equals to 4, y is 45. So here we have x is equals to 4 and then y is 45. Wow, it's way up here. So this is where the curve is going to be. Now let's find out where the curve of this is going to be, whether it will be here or here. So let's pick a number that's at the left of the vertical asymptote. Let's pick 2. So we're going to have that y is equals to 3 multiplied by 2 square minus 2 plus 1, then divided by 2 minus 3. So 2 square is equals to 4. 3 times 4 is 12. 12 minus 2 is 10. 10 plus 1 is 11. Now it's going to be 11 divided by 2 minus 3 is minus 1. So it's going to be minus 11. So the coordinates are going to be 2, minus 11. So here is 2, and then minus 11 is going to appear, this side of the graph. So basically this side. So it means that this curve is going to look like this. So this is the end of the video. Thank you for watching. Please remember to share with your friends, like this video, and drop your comments. Have a great day.